Let's look at another example of the builder pattern in action. This is a much more interesting example in my opinion and really shows the power of the builder pattern and specifies the kind of cases where you might use this. This is the SQL query builder. So what is a SQL query? A SQL query is to get information, update information from a relational database. These queries typically can get very complex indeed, and there should be a way to abstract the user away from its complexity and kind of be able to specify a query bit by bit. This is what the SQL query builder does for us. So what does a database contain? It contains data in rows and columns, basically a bunch of tables. It contains a way to define relationships between these rows and columns and a way to get data into and out of those tables. This is what a database management system is. The data in rows and columns are tables. The relationships between these rows and columns are the relationships. And how do you get data in and out? Via queries. You specify the relationship between the rows and columns that is present in a database using a DDL or a data definition language that's used to specify relationship between tables. You use a DML or a data manipulation language in order to get data in and out of these databases. That is the DML. Now, if I ever use a term relation when I'm talking about databases, it's basically a synonym for table. A table is exactly the same as a relation. This is a DBMS or a database management system. Let's take a look at what are the things we can do with a database management systems. The first is we can create tables. These are the tables we want to use to set up relationships. We can create them. They only become useful when you put data into tables. We want to use that data so we can take data out of tables. Now, if we no longer have use for some data, we can delete data from tables. In fact, it could so happen that we no longer need a table itself, so we can delete tables. We can change the data in a table, that is, update data in tables, or update the table itself. The structure of the table itself can change. Lastly, we can specify conditions and relationships in the data, amongst the data in the tables, that should always hold true. This is pretty important. When you have data in tables, you want to be able to specify constraints on them or conditions which should always hold true no matter what the data is. So creating tables, you want to be able to define columns, define what the header is in a file. That's what a column is analogous to. Alright, putting data into tables. So we insert rows into tables. Since data is rows and columns, when we insert rows, that's when we put data into tables. Taking data out of tables, we can get specific rows and specific columns from different tables together. We can delete rows from tables. We can also change the existing rows in tables. And when we update tables, that is, change the table structure, we can add and remove columns from these tables. What about the conditions and relationships? These need to be checked each time any table or its contents change. Only then will we be able to ensure that the constraints are always true or always met. Let's focus on taking data out of tables and what we need to do to achieve that. This is called querying. This involves only reading the data from the table and not changing it or updating it in any way. It's not writing. We use the DML or the data manipulation language for this. SQL or SQL. This stands for Structured Query Language. So what is SQL? This is a simple language that can be used to accomplish all 8 of the tasks that we saw on the previous screen. SQL enables us to perform all 8 of the common tasks on a database management system. SQL is a language which is understood by all relational DBMSs. There are different kinds of DBMSs, but we won't worry about those for now. With slight variations in syntax, SQL is understood by all relational databases. So SQL commands can be called from within programming languages. They can be called on the database console, but they also can be called from within programming languages such as Python or Java. SQL is so cool that it is one data manipulation language used to accomplish all 8 of those tasks and can be called from within programming languages as well. SQL is actually an important reason why using a DBMS is far more convenient than using files for persistent storage. SQL helps you do a whole bunch of things, including setting up constraints on the relationships. So SQL is convenient. Let's see one example of a SQL query before we move on to talking about the SQL query builder, which follows the builder pattern. We'll look at the create table SQL syntax. Here we want to create a table named person, which holds all the information about a particular person. Each row corresponds to information about one particular person. So we'd say create table person, ID, which is the unique ID, first name and last name. These are the columns in our table. So person is the table name. ID is an integer attribute of a person. First name and last names are both varchars, meaning they are simple strings. That's how it is in real life. Within the brackets, we've actually specified a list of column name, column type pairs. The primary key basically is a uniqueness constraint of ID. It indicates that the ID for every person should be unique, and that is what is used to index the table. Basically, any lookups by ID will be very fast. That's what primary key means. Primary key can be for a column or a group of columns. Executing this command will create an empty table which has 3 columns, as we've seen on screen, the ID, first name and last name. But since we've put no data yet on this table, it has no rows. Now that we've seen a brief overview of what SQL is, let's now go on and build the SQL query builder. This is a class which uses the builder pattern in order to construct a SQL query for you.